Hello everyone, welcome back to the Atharva Academy. Myself Chinmay Dhaduk. Now in this video, we are going to start chapter 7, that is combined stress and strain. In previous chapters, we have discussed that how to find stress in axial loading condition, in torsional loading condition, and in bending loading condition. Now in axial and in bending there is normal stress produced, right? Normal stress. And in torsional loading there is shear stress produced in the body. Fine. So we have discussed that how to find normal stress and shear stress in this type of loading condition. But in that cases there was only one type of loading condition, right? There was either axial loading condition or torsional loading condition or bending loading condition. But if we have, let's say, any body like this, and we have different type of combination of these loads, means let's say we have axial load like this, we may have transverse load like this that we have discussed in the beam, right? And we can also have torsional load on this body. Fine. So in that case, how to find stress and strain in this body? To find stress and strain in combined loading condition, we have to understand this chapter, that is combined stress and strain. In this chapter, we will understand that how to find stress and strain in the combined loading condition. Fine? From this chapter, you have to remember lots of formulas, and you have to understand that how to use that formulas to find out combined stress and strain. Means you have to understand that how to find normal stress and shear stress and normal strain and shear strain. Fine? Now what is combined stress? So we can say that normal and shear stress applied at a point is called as combined stress. Let's say if we have any body and in that body we have normal stress in the body and we also have shear stress in the body, then we can say that in that body there is combined stress. Fine? Now we are going to derive equations to find out normal and shear stress in the body on any plane. Fine? Let's say we have this type of body and in which we are going to apply stress in this direction, that is normal stress. Let's say this direction is x direction, so this stress is sigma x. This is normal stress in this body. Here in y direction we are going to apply stress sigma y. Here this stress is perpendicular to the surface, so it is normal stress. Now we are going to apply shear stress that is parallel to the surface. So it is like this. Let's say this stress is tau. And let's say this shear stress tau is tau x y. And we are assuming that on this surface this shear stress is in this direction. And it is having same value. So due to this body will be in equilibrium, right? Now in this surface we are going to apply shear stress in this direction, like this, and here it will be in this direction. So this body will be in equilibrium, right? Now you can see that in this body these stresses are applied in only two directions, that is x direction and y direction. Means in this case we don't apply stress in z direction. Means we can also say that this condition is the condition of 2D loading condition. Now in this body we are going to take one plane like this, which is at angle theta, and we can also say that this plane is oblique plane of this body, and here this inclination of this plane from this vertical line is theta. Now we are going to derive formula to find out normal stress and shear stress on this plane which is inclined at theta angle. Fine? Now on this plane there will be normal stress in this direction, right, sigma n, and this direction is perpendicular, and there will be this shear stress on this plane which will be in this direction, means it will be parallel to this plane, and it is tau. So actually we are going to derive equation of normal stress and shear stress on this plane which is inclined at angle theta. Now here I am only going to tell you that how to derive this equation, and then I will directly give you the equation, because forget derivation is not so much important, right? Let's say here this point is point A, this point is point B, and this point is point C. So we are going to take this triangle ABC here. So it will be like this, A, B, C. Here there is normal stress in this direction and shear stress in this direction. Here there is sigma y, and here there is sigma x, and we have also shear stress in this direction and in this direction. Fine. Now here I have shown this triangle here, and in this triangle we will take this point as point origin, and here we will take this direction as, let's say, x dash direction, and this direction as y dash direction. Now we know that here this triangle is in equilibrium. So here sum of forces in x dash direction is equal to 0, and sum of forces in y dash direction is equal to 0. Now remember that we cannot take sum of stresses is equal to 0. We have to take sum of forces. Fine. This angle is angle theta. So from here we can say that cos theta is equal to AB divided by AC, right? And sin theta is equal to BC divided by AC, right? And here we are taking width of this plane as unity, means we are assuming that width of this body in the direction which is perpendicular to the screen is unity. So here area of this surface will be AB into 1. Area of this surface will be this AC into 1, and area of this surface will be this BC into 1, right? Now we know that force is equal to stress into area, right? And it is also equal to shear stress into area. This is normal stress into area, and this is shear stress into area. Fine. Now first of all, on AB surface there will be load in this direction, let's say it is Fx, and it will be sigma x into area, that is AB into 1, right? So here I will write AB, and here in this direction there is shear stress tau x y. So here in this direction there will be force due to this shear stress, that is tau xy into area, that is A into B. Here this width is 1, so area is AB, right? Here width of this body is 1, so area is length AB, this, right? Now similarly on other sides, side BC and side AC will also have this type of forces. Now similarly on this surface there will be force in this direction is sigma y into BC, and there will be stress in this direction which is tau xy into AB, right? And similarly on this surface there will be force in this direction and in this direction. So here I will write in that at this point in this direction there is force tau into AC, and in this direction there is force sigma n into AC. Fine. Now in this case this angle is angle theta, and here this angle is 90 degree, right? And here we also know that we take this direction as x dash direction and this direction as y dash direction. So now if you will resolve these forces in x dash direction and y dash direction, then you will get value of sigma n and tau in terms of sigma x, sigma y and tau xy and also theta, right? Now I am directly going to give you equation to find out sigma n and tau, because derivation of these equations are not necessary. Fine. So finally you will get equation of normal stress at any plane on this body, that will be equal to sigma n is equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 into cos 2 theta plus tau xy into sin 2 theta. And you will get equation of shear stress at any plane, tau is equal to minus sigma x minus sigma y by 2 into sin 2 theta plus tau xy into cos 2 theta. So you have to remember these two equations. Fine. And here this theta is taken as positive if you will take theta in this direction. If plane is given like this and this theta is given, then you have to take this theta as negative. Means if this theta is given as 30 degree, then you have to take minus 30 degree in this equation. And if it is given in this direction, means if this angle is 30 degree, then we have to take this 30 degree as positive. So if this is the case, then we will take this theta as plus 30 degree. Fine. So here this is the equation to find out normal stress on this plane. And here this sigma n will be in this direction because it is normal stress. And this is the equation to find out shear stress on this plane, that is tau. Now let's say if you find value of stresses on this body at different value of theta, means on different planes of this body, you will get one plane at which value of shear stress will be 0. And plane on which value of shear stress is 0 is called as principal plane. Means we can say that plane in the body on which value of shear stress is 0 is called as principal plane. Means on the principal plane of body there will be only normal stress in the body. There will be 0 shear stress on principal plane of body. Let's say if we have this type of body on which in x direction we have stress sigma x, which is normal stress, and in y direction we have normal stress sigma y, and there is no any shear stress on this body, means tau xy is 0 in this case. Means here if you will see value of stress on this plane for which theta is equal to 0, you can see that on this plane there is only normal stress present in the body. There is no any shear stress on this surface of body. So this plane will be principal plane for this body. Now you can see that on this plane of body for which theta is equal to 90 degree, there is also normal stress on this plane. Means on this plane there is only normal stress sigma y. There is no any shear stress acting on this plane of body. So this plane of body is also called as principal plane of body. And value of normal stress means value of sigma n at principal plane is called as principal stresses, and that is denoted by sigma 1 or sigma 2. Means here stress on this plane and stress on this plane is principal stress in the body. And whenever there is shear stress is 0, value of normal stress will be either maximum or minimum. And here maximum value of principal stress is denoted by sigma 1 and minimum value of principal stress is denoted by sigma 2. So what I have discussed? I have told that plane on which value of shear stress is 0 is called as principal plane, and normal stress on the principal plane is called as principal stress in the body. Fine? So now there is an equation to find out plane of maximum principal stress. And for maximum principal stress, theta is called as theta p. Means at an angle of theta p, there will be one plane which will be plane of maximum principal stress. And to find out plane of maximum principal stress, means to find out theta p, we can use this equation. Tan 2 theta p is equal to 2 tau xy divided by sigma x minus sigma y. So by using this equation, you will be able to find plane of maximum principal stress. Fine? And actually this equation is derived from equation of normal stress sigma n. To derive this equation, we have to take d sigma n by d theta. Here this is the part of mathematics. If you want to find maximum value of any variable with respect to another variable, then you have to take differentiation of that variable with respect to that another variable. So here if you will find maximum value of sigma n with respect to theta, then you will get this expression. Right? We will also discuss that how to find this maximum value of any variable with respect to another variable in the subject of engineering mathematics. So right now you have to remember this equation. Fine? Now here if we will take different planes at different value of theta, then we will get one plane at which there will be maximum value of normal stress. And plane on which there is maximum value of normal stress is called as plane of maximum normal stress, and which is also called as plane of maximum principal stress. Remember that normal stress is also called as principal stress. Fine? So we will get one plane on which there will be maximum value of normal stress. And to find out maximum value of normal stress, we have to take d sigma n by d theta. This is the part of mathematics. To find out maximum value of normal stress, we have to take derivation of that stress with respect to theta. And if you will do so, then you will get this expression, that is tan 2 theta p is equal to 2 tau xy divided by sigma x minus sigma y. So if it is asked that find plane of maximum normal stress, then you have to find out theta p. Now similarly, there will be one plane on this body at which we will get maximum shear stress, and that plane is called as plane of maximum shear stress. Fine? And to get that plane, we have to take d tau by d theta. Means we have to take derivative of this tau, that is this expression with respect to theta. And if you will do so, then you will get this equation. Here this theta s is the angle from this vertical surface in this direction, and where we will get one plane on which there will be maximum value of shear stress on this body. Fine? So to get plane of maximum shear stress, we have to find out theta s from this equation. And here there is minus sign in this equation. Fine? So you have to remember these two equations also. Now here this is the plane which is at theta angle, and this is the value of normal stress, and this is the value of shear stress on the plane which is at theta angle from this vertical side. Fine? Now we are going to take another plane which is at 90 degree from this plane. Means actually this plane in this body is at the angle of theta plus 90 degree from this vertical side. And let's say we want to find normal stress in this plane. So here normal stress in this plane will be perpendicular to this direction, right? And let's say it is sigma n dash. So to find out sigma n dash, we have to take theta is equal to theta plus 90. Fine? and we already have value of sigma n. That is this equation. So if you will take sum of normal stress at theta angle and normal stress at theta plus 90 degree angle, then you will get sigma x plus sigma y. Means it is equal to normal stress in x direction plus normal stress in y direction. Fine? Here these stresses are complementary stresses because direction of both the stresses is perpendicular to each other, and here this value is constant. So we can say that sum of complementary normal stresses is always constant. And let's say here in this plane shear stress is in this direction, which is tau dash. So here we can say that this tau dash is shear stress on this plane, which is at angle theta plus 90 degree. Fine? So to find out tau dash, we have to put theta is equal to theta plus 90 degree. And if you will find tau dash from here, then you will get this tau dash as minus tau. Means you will get this equation into minus 1. So we can write that tau plus tau dash is equal to 0. And here these shear stresses are complementary shear stresses, because here this shear stress is having direction perpendicular to each other. So from here we can write that sum of complementary shear stresses is always 0. In this case, sum of complementary normal stresses is constant. Fine? Now from here you have to remember other two formulas, that is formula of maximum and minimum principal stresses on the body, and other formula is maximum shear stress on the body. Here in this equation, sigma 1 2 is equal to sigma x plus sigma y by 2 plus or minus root sigma x minus sigma y by 2 whole square plus tau xy square. Now here sigma 1 is maximum value of principal stress and sigma 2 is minimum value of shear stress. We have discussed that sigma 1 and sigma 2 is the value of principal stress on the principal plane on body, at which value of shear stress is 0. Fine? And here this sigma 1 is maximum value of principal stress, means we can say that maximum value of normal stress, and this sigma 2 is minimum value of shear stress. For maximum value we will take positive sign, and for minimum value we will take negative sign. So if it is asked to find out maximum and minimum principal stress in the body, then you have to use this formula. Fine? Now this is the formula to find out maximum shear stress, that is tau maximum is equal to sigma 1 minus sigma 2 by 2. And we can also say that tau maximum is equal to sigma x minus sigma y by 2 square plus tau xy square under root. Fine? From here if you will take equation of sigma 1 and equation of sigma 2, and you will take sigma 1 minus sigma 2 by 2, then you will get this expression, and which is equal to maximum shear stress in the body. See, here you have to remember these formulas, because in the GATE there will be direct question from these formulas. So these all formulas are very important. Fine? Now from here you also have to remember other two formulas, that is for magnitude of maximum shear stress. Here this maximum shear stress is for 2D case. Means in this case we have applied 2D loading condition in the body that we have discussed earlier, right? So in that case value of tau max is sigma 1 minus sigma 2 by 2. But if there is 3D loading condition, means if we apply stresses in x direction, we apply stress in y direction, and we also apply stress in z direction, then that case is the case of 3D loading condition. And in that case, if you want to find out maximum shear stress tau max, then we have to take absolute maximum means larger of these three values. Larger of sigma 1 minus sigma 2 by 2 in the mode, sigma 2 minus sigma 3 by 2 in the mode, and sigma 1 minus sigma 3 by 2 in the mode. So if let's say this value is 50, this value is 20 and this value is 40, then we have to take maximum shear stress as 50. Fine. And if in the question it is mentioned that this case is the case of plane stress, means in z direction value of stress is 0. So in that case here this sigma 3 will be 0. So this expression will becomes like this. Means here we will have maximum value from these three terms. So in this case, if this value is 20, this value is 10 and if this value is 30, then we have to take maximum shear stress as 30. Fine. So there may be confusion to find out maximum shear stress in the body. So understand carefully that if it is mentioned that it is the case of 2D, then we have to directly take sigma 1 minus sigma 2 by 2 as maximum shear stress tau max. Now if in the question it is mentioned that this case is for 3D case, then we have to take maximum shear stress as maximum value of this 3. And if in the question it is mentioned that this case is for plane stress condition, then we have to take maximum shear stress tau max as larger of these three values. Fine. And if nothing is mentioned in the question, then you have to take maximum value of shear stress from this expression. Means if it is not mentioned that it is 2D case or it is 3D case or it is plane stress condition, then we have to take this case as 3D case, and if sigma 3 is not given, then we have to take sigma 3 is equal to 0 and we will take larger of these three values. Fine. So I hope that you understand how to find maximum shear stress in different conditions. So from this chapter you have to remember lots of formulas, and once you will remember this formula, it will be very easy to solve questions of combined stress and strain. Fine. Now from today's video you have to remember these formulas and you don't have to remember derivation of these formulas. Now today we will stop here and we will continue in the next video. Till then, stay motivated and happy practicing.